Skylab was constructed from repurposed Apollo hardware, designed to prove humans could live and work in space for months at a time. The architecture included a massive orbital workshop built into a Saturn rocket stage, an airlock module, a multiple docking adapter, and a dedicated solar observatory called the Apollo Telescope Mount. It was the heaviest spacecraft ever flown. But if engineers and astronauts couldn't reverse engineer a fix for the launch damage, the entire American space station program would end on its very first day. The crisis began in the lower atmosphere. Under immense aerodynamic pressure, a design flaw allowed air to rush under the station's micrometeoroid and thermal shield, peeling the protective layer completely off the hull. The tearing metal initiated a chain reaction. The shield snagged one of the main solar array wings, ripping it entirely off the spacecraft. Debris and exhaust plumes from the rocket staging then wrapped around a remaining wing, permanently pinning it shut. Looking at this post-mission engineering report, we can see the immediate threat. Without the thermal shield, the station's bare metal hull absorbed the full brunt of the sun. Temperatures inside the orbital workshop rapidly climbed past 130 degrees Fahrenheit, creating a serious risk that plastic insulation would melt and fill the station with lethal toxic gases. The document also highlights the secondary electrical failure. Without the two main solar wings, Skylab lacked the power to operate its life support systems and scientific equipment. The station was suffocating in the heat and starved of electricity. No automated command from Houston could replace a torn shield or cut away mangled debris. Saving Skylab required human hands. Down in Houston, Mission Control immediately commanded the dying station to pitch upward. Changing Skylab's orientation relative to the sun reduced the thermal load just enough to buy time, forcing managers to delay the launch of the first crew by 10 days. Ground teams began a frantic sprint of rapid prototyping. Jack Kinsler, head of the Technical Services Division, devised an emergency sunshade made of laminated nylon and mylar. His team designed it to fold up like an umbrella so it could fit tightly beneath the crew's seats inside the command module. Simultaneously, astronauts plunged into massive neutral buoyancy tanks. Working entirely underwater with mock-ups of the station, they invented and rehearsed emergency spacewalk procedures to physically pry the jammed solar array loose. On May 25th, astronauts Pete Conrad, Paul Weitz, and Joe Kerwin finally launched. When they reached orbit and flew their module around Skylab, the damage was undeniable. They stared out the window at blistered gold skin, a tangle of severed cables, and the thin metal strap pinning the solar array tight against the hull. They immediately attempted a repair. With Kerwin holding his legs, Weitz leaned out of the open command module hatch into the vacuum of space, wielding a makeshift aluminum pole with a hook on the end. He yanked at the jammed panel, trying to force it free, but the debris wouldn't yield. The brute force attempt failed. Now the crew had no choice. They had to dock their module, open the hatch to the 130-degree workshop, and attempt to fix the station from the inside before the heat destroyed the internal systems. Entering Skylab was like stepping into an oven. The crew moved in short shifts, constantly retreating to their docked command module to escape the suffocating heat. Their first target was a small scientific airlock facing the sun. They pushed the folded parasol assembly through the narrow port. Once it cleared the exterior wall, the mechanical arms swung open, blossoming outward to cast a massive shadow over the exposed metal. Reading this material evaluation report confirms the immediate impact. The laminated nylon and mylar effectively block the solar radiation. Within 3 days, the internal temperature inside the orbital workshop dropped to a habitable level. The heat crisis was over, but Skylab was still crippled by the power deficit. The crew had stabilized the environment, yet without the main solar array, they lacked the electricity to run the vast majority of their planned scientific experiments. 2 weeks into the mission, Commander Pete Conrad and Joe Kerwin suited up for an incredibly high-stakes spacewalk. Their objective was to climb outside the station and physically cut the metal debris trapping the solar wing. The exterior was not designed for this. There were no handholds near the jammed array. The men had to rig a makeshift tether system just to reach the site, awkwardly maneuvering a 10-foot-long pair of cable cutters borrowed from a ground utility toolkit. Anchored by their tethers, they heaved against the heavy shears. The metal straps snapped, and the frozen array burst open, violently throwing both men backward. Electricity immediately flooded back into the station's grid. By successfully freeing the array, Conrad and Kerwin proved that humans were highly capable mechanics, able to execute heavy, unplanned construction in a vacuum. With full power restored, the Skylab program proceeded. 3 successive crews lived aboard the station, staying for 28, 59, and finally a record-breaking 84 days. They captured nearly 30,000 images of the sun using the Apollo telescope mount, gathering massive amounts of data in X-ray and ultraviolet wavelengths that ground-based observatories simply could not see through the Earth's atmosphere. The crews also served as their own test subjects. Through rigorous daily monitoring in devices like the lower body negative pressure experiment, they tracked exactly how human cardiovascular and muscular systems degrade in zero gravity. They developed the physical exercise routines and dietary countermeasures necessary to keep humans healthy in space. Every piece of physiological data collected aboard Skylab became the foundational blueprint for designing the International Space Station decades later. While the thousands of hours of solar observations and medical readings provided a technical foundation for the future, the station's most significant legacy is the story of its rescue. A catastrophic launch failure had crippled a multi-billion-dollar asset, but ground controllers accurately diagnosed the damage from Earth. Engineers designed custom repair tools in a matter of days, and astronauts physically rebuilt the spacecraft in orbit. It was the ultimate proof of concept for human adaptability in space. By 1979, atmospheric drag pulled the empty station back down to Earth. It broke apart upon re-entry, showering sparsely populated areas of Western Australia with scattered debris, leaving behind only scourged artifacts in local museums. This video is brought to you by Cosmora HQ. As we look toward future manned missions to Mars, the ability to improvise and repair complex hardware will be a matter of life and death. What lessons from Skylab's rescue do you think are most critical for deep space exploration? Let us know in the comments below, and make sure to like and subscribe for more deep dives into space history.